Good evening. Welcome to the Infinite Impulse Response Filter Design, which is also known as the IIR filter. An IIR filter is one of two primary types of digital filters used in digital signal processing application. The other type it is FIR, which is known as the Finite Impulse Response. On this presentation, I'm going to focus more on the methodology and results. On this slide, I wrote down the steps that I followed in order to design the IR filter. The first step is that I calculated the board plot using the MATLAB software. I calculated the poles and zeros. I calculated the IR coefficients. I calculated the quantification error. And the last one, which is of importance, I drew the basic structure of the IR filter on LabVIEW, and then I substituted the calculated IR coefficients on the basic structure of the IR filter. The results. On this slide, I've shown the formulas I've used to calculate the poles and the zeros. And as you can see, the formulas are a bit the same, but when it comes to substituting, they will be a bit different. When you calculate the poles for frequency, you use the signal frequency. And then also when you multiply that part of adjacent equals to cos of 634 times 0.7, you're gonna multiply with 0.707 because of the rule of the unity circle, which states that the poles there must be a distance of 0.707 from the cycle. But when you calculate the zeros, you use the noise frequency, and then also you multiply with 1, which means that the zeros can be put anywhere where you want to put them. On this slide, which still talks about the results, it shows the coefficient, the IR coefficients, how I calculated the IR coefficients. As you can see, they are calculated B0, B1, B2, and A1 and A2. Results on the board plot. This is not the actual board plot. The actual board plot, it will be shown on the next slide, which I drew using MATLAB software. Coming to this slide, as you can see that there are two frequencies, the signal frequency, which is the first one, and the second frequency, which is the noise frequency. As you can see, when the line goes towards the first signal, it's still a high, but it's decreasing, but it's not going to zero. As it reaches the 170 frequency, which is the noise frequency, it goes towards zero, which shows that the unwanted frequency, which is the noise frequency, it's been filtered out. This is the graph of the f of t, and then the amplitude are the same for the signal frequency and the noise frequency. On this slide, it's the board plot that I drew, or MATLAB drew for me when I typed a code on it. As you can see there, I've wrote 130, which is my frequency, the signal frequency, and then I also wrote the 175, which is the noise frequency, the unwanted one. As you can see, this board plot, it's quite similar to the one that I just saw right now, which was an example from the lecture. As the blue line gets to the 175, which is the noise frequency, it goes down towards zero, which shows that this design, it is filtering out the 175 frequency, which is the noise frequency. And then by this I can say that I can say that my design, it is working, or as time goes on with improvement, can filter out the unwanted frequency. Thank you.